It's worth spending a couple of words on this example because it showcases a programming pattern that's very common, and that's called the accumulator technique. It's a combination of iterative processing with a loop and of the use of one variable, the accumulator, that actually is used to, well, in this case, accumulate the result of a sum. So if you look at what's happening here, we ask the user for some input, a number, and if that the user input is not towards sum, but it's actually a number, we convert that to a numeric type and we sum it to the total, and then we ask for new input. And we keep doing that, and each time this total gets incremented by the new number that the user has given us. At the end, this will contain the sum of all the numbers. So you may think that in order to sum a list of numbers, you need to have and keep all the list of numbers in memory, but that's not the case. It wouldn't be practical if, for instance, this list of numbers is very long, like say 1 million numbers. But that's not what you would do either if I'd asked you to keep a total of numbers that I'm telling you. So if I keep telling you numbers 5, 7, 12, and your task is just summing them, what you would do is you would compute a running sum. And that's exactly what this total does. If you want, you can try to display that. Running total is, and let's use the F syntax to print out that total, and let's see how this works. So you enter 5 and the running total is 5, and then you enter 2 and the running total is now 7 because that's 5 plus 2, and then you enter 4 and it becomes 11, and then finally you ask for the sum and that returns 11. Also note how this is a very typical case for using the while loop, because we don't actually know beforehand on how many items we're going to operate, nor which exactly are these items, so the user enters them one by one. And therefore, in this case, normally you want to use a while loop.